Right. Welcome everyone to our fifth lecture of the introduction to programming with R. Just allowing people to connect. We should be streaming and recording. So before we start the class, I have an announcement for you guys. I think you will like it. At least some of you were asking for this. So I created in the course webpage a new folder, a new set of pages actually called exercises. By the way, let me know if you are not listening. You should be able to hear what I'm saying. Just want to double check. I think you should be able to see and listen to me. Please, otherwise, let me know. Okay, perfect. Thank you, Tashinder. Perfect. Thank you. And so what I did was I collected and created a series of exercises. So these exercises, just to be clear, are not mandatory. So they are not going to be counted as assignment or homework or anything like that. It's mostly for you to practice. And so far I have three. I came up with three exercises which I think are kind of interesting. But as I say, this is only if you want to practice, to put in practice the skills that you have learned. So we have one that I won't go through all of them because some of them are a bit lengthy and they are not as structured as the assignments themselves. So the idea here is that you can practice and experiment a little bit, and it's more a guidelines of what kind of things you can try to do. So one thing I try to do as well is to guide you about the level of the exercise, so what kind of level I believe it is, and you are welcome to provide me feedback because this is mostly based on what I think it could be. But this is important for me to hear about you if you want to try them. So I had basic ones, I had medium or advanced ones. And as I say, I think it's a good thing. So for instance, this is exactly the assignment that you are working on right now, assignment number 2. But what I'm asking you to do is to solve the problem not using slicing or vectorization, but using looping. So instead of slicing and vectorizing your operations of the vector, I guide you here. This is the main logic, the main code that you will need to implement if you want to do the exercise, the assignment number 2 using loops. Again, this is not for the assignment, this is just an exercise based on assignment number 2 if you want to practice. And I have some comments here, so it's more as a playground, I will say, a sandbox for you guys to play and try something else if you feel that you would like to. And this is a medium exercise, and then there is this is a very interesting one. I will say is final difference, and it combines some numerical techniques plus something that I think Richard was mentioning a couple of lectures ago, recursivity. So I kind of guide you through that. So just to warn you, the level of the exercises are different, so that's why I put at the very top what type of level it is. So again, something that if you want to practice, you are welcome to, and I'm happy to take questions about this. And some of you were asking for them, so or asking for resources. So I didn't really know any good resources of exercises, so I thought that this can help to practice a little bit more and push yourself. So that's another thing, you will have to push yourself a little bit more than the usual assignments. Okay, again, if you have any questions, just let me know. In the meanwhile, any questions about assignment 2? We had office hours yesterday at 1 p.m. I think there were a couple of questions. Some people were having trouble with the eHelp package, which is needed for testing that your doc strings are working. No problem, my pleasure. If you find yourself that eHelp is asking for a package called Crayon, just do install packages Crayon in the same way that you will do the eHelp installation. to be honest with you shouldn't be requesting that unless you are using directly the eHelp function. If you are using the help function, it shouldn't matter at all, but for some reason it's asking for that. So other than that, I think most of the questions were about interpretations of things like that. Another thing that came up a couple of times already is in the admin when I mentioned that the condition of number should be equal and greater than 0. Don't sweat too much about that. To be honest with you, those numbers are going, so the null element 0 will be basically excluded when you do your odd condition, right? So for when you use the post only arguments, don't sweat it too much about that. Okay. Any other questions about assignment 2? I mentioned the exercises again. They are completely optional. This is not part of the course itself, so it's part of the course, but it's more for practicing than for evaluating your performance in the course. Okay, so the topic for today, we're going to be talking about a couple of things that actually come together under the umbrella of high dimensional data. So we're going to be talking about matrices, arrays, and data frames, or arrays and matrices and data frames. So just a quick recap from last week. We talked about vectors. You are working with vectors right now in assignment number 2. One of the main elements of vectors that this is a homogeneous type, meaning that all the elements in the vector are of the same type. They are compact. They cannot be nested. And here are some examples how we can define vectors using the C function. And this is a numeric vector. This is a vector of strings or words. This is another numeric vector using the colon operator. And the structure will tell you about what type of data is stored there. I don't think I mentioned this one. This one we may come back when we talk about statistics, which hopefully will be next week. Is the sample function. So the sample function is super useful. It's a function that allows you to sample randomly. And this word is important, and this is the word that we're going to be discussing furthermore with way more detail next week. So what it will do is it will take a couple of arguments. So for instance, 1 to 10 is a vector, and then 4 is how many elements I want to sample randomly from this vector. So my vector goes from 1 to 10, so randomly I will pick 10. I will pick 4. And the interesting thing is that if you do this several times, you're running exactly the function, and actually if you run it in your terminal, these numbers will change all the time because those numbers are random. They are randomly selected from the vector that you provide to the sample function. Now the sample function has another argument which is sometimes useful, is to say replacement equal true. So it turns out that if you use the sample function with a vector and the number of samples that you want to take, those numbers cannot be repeated unless you allow the function to do a replace equal true. So the usual case here is like the typical exercise in probability where you have a bag with balls with numbers, and then you start taking out numbers from the bag of balls. And so let's say I have a bag with 10 balls numbered from 1 to 10. So if I take the first one, it's 9. So 9 cannot be in the bag again. So I take the next one, 5. So this is basically sampling with replacement or not. So in this case, if you say replacement equal true, then 7, which was taken, can be taken again because that number comes back to the bag at the end of the day. Okay. Sample can be used with any kind of vector, a Boolean vector in this case, with true and falses. And then notice this, right? This is important because if I want to have more samples than the total number of elements in my vector, it's mandatory that you say replacement equal true, because otherwise with a vector of 2 samples, true and false, I can only have 2 samples, right? Otherwise it will basically just crash because there are not enough elements in my vector. 5 is repeated in the second. Okay, yes, but this is a good point, Jennifer, thank you. This is a different set, right? So I run sample 1, my vector is 1 to 10, I take 4 numbers from there, so 5 cannot be repeated there. And then I run sample again, so it's a new vector 1 to 10, so it's not repeated within the samples that are taken every time, right? Okay, is that clear? So first sample, second sample. These samples are what they are called, or we are going to assume under the sample function, they are independent random variables. That's the technical name that probability people give to them. Independent random variables or independent random samples. So these are different bags of balls. It's within the same bag, but you cannot take the same number again. Okay, it's a good point. So the other point is that if you are running this command in your computer, these numbers will change most likely because it's a different sample that you are doing from the same vector, right? And if I do it right now, it will also change. Okay, let me know if that is clear. Again, this is a very important and very fruitful topic. I think we are going to spend some more time next week, and depending on when we end up doing, I may have an assignment for you, and if not an exercise, which I really like that type of exercise, which is a Monte Carlo technique where random samples are used very heavily. Okay. Again, Jennifer, let me know if that is clear. So so that was a little bit of an introduction to our vectors and recap to the vectors. Perfect, thank you. And I'm going to just now crank up a little bit the dimension because a matrix, I hope that most of you are familiar with matrices, are nothing else than a generalization of vectors. You can think about matrices as a collection of vectors, either as row or columns. But basically a matrix is a higher dimensional mathematical object. So the matrix function is the one that allows you to basically generate matrices in R, and of course matrices in R are going to be two-dimensional, and we're going to see how to generalize that, but so far matrices are two-dimensional. Basically you can specify number of rows and number of columns, and here what I'm doing is defining a matrix capital A, taking the R norm function, that's the random normal function. That means it's a function, and again we are going to dive with much more detail next week on all these functions. Is taken from the normal distribution random numbers, 9 of them, and is going to place them in a matrix with 3 rows, which of course means 3 columns as well. So if I ask for the class of A, it's a matrix, and if I ask for A, these are the values. And again, if you execute this line in your computers, most likely these values will change. Okay. Then we have the property that will go from minus a certain value to positive values because it's from the normal distribution. But again, I will come back to this point. So far, I just want to show you how you can create a matrix. You can provide 9 numbers in any kind of form. I'm just using this function because it's convenient. In the same way, you can specify number of rows and number of columns, and you can have matrices that are not a square, because I'm giving 9 numbers and 3 rows. This is going to be a square matrix, but I can have a rectangular shaped matrix if you want. How to perform operations in matrices is in R by default are element by element. What this means is I'm going to create another matrix here, 1 to 6 values. So instead of using the R norm, I'm going to give a vector 1, 2, 3, 4, 5, 6. I'm going to say that I'm going to have 3 rows, which means this is going to be a rectangular matrix now, and this is the value of the matrix. So if I look at that, so first column, first row, second row, third row, and then I'm going to create a second matrix from 1 to 6 plus 1. So this vector is going to be shifted by 1 with 3 rows as well. So if I look at the matrix it starts at 2, 3, 4, 5, 6, 7. Okay, and now if I do the multiplication, so I just use the asterisk of the star operator, and I do A times B, then what happens is each element is multiplied by each element. So 1 times 2 gives me 2, 4 times 5 gives me 20, 2 times 3 gives me 6, and so on, right? If I do A minus B, because the way we define the function with this offset of one value is just to give you a matrix full of minus ones. Okay, but you can see that from here as well. 1 minus 2 gives you minus 1, 4 minus 5 gives you minus 1, and so on. So whenever you use these operators, these simple operators like division, multiplication, subtraction, or addition, they operate in an element by element basis. That's what it means. It takes each of the elements and do that. I think MATLAB, if you have used, they do something like that. So the convention changes depending on the language, but that does element by default. Okay. Now, there are another good things in R that, for instance, allow you to solve linear systems. So a linear system is nothing else but a matricial equation given by A, a matrix, times X, a vector of unknown, equal to B, a vector of constant values. So you can solve for X. This is a very typical problem that arises from fields like ODEs or stability systems, those kind of things. And usually the name of the game is solving for X. So basically what one will do in high school or first year of linear algebra in the university is learn some methods to solve this. And one of the methods, the most direct one, is, remember, matrices operations are not commutable, so you cannot permute the order of operations. So I had to hit the left side with the inverse of the matrix A, and similar here. So if I do inverse of the matrix A times A, that gives me the identity matrix that allow me to take X, and then here I had to do inverse of A times B, and that will be the result of the unknown X. Now, turns out that even when mathematically nice and elegant, this procedure of computing the inverse of a matrix, especially if you have very large matrices, is very costly when you do it in the computer. So computationally, inverting a matrix is one of the most expensive operations you may have, and furthermore, sometimes because several issues with the way that computers represent numbers, it can allow you, or it will hit you, some numerical instability. So one thing that we always try to do is try to avoid to compute inverses of matrices. So the good news is, depending how you install R, and this is mostly true when you're going to run R in a supercomputer center or in a high specified or high explicit cluster, those installations of R are tied to what we call linear algebra libraries, specialized linear algebra libraries that uses very specific and specialized routines to allow to compute these kind of problems in a very efficient and robust manner. So you don't need to worry about this. I just wanted to let you know. But let's say that we have this matrix. This can be the matrix that we generated at the very beginning with the 9 random numbers. Then let's say that our constant vector B is just 1, 2, 3. And notice that I'm going to show you how to perform what is called inner product. So basically this is well, not inner product yet, but this is mostly a matrix vector multiplication. That's the usual operation that you will expect to have when you have a matrix and a vector. So basically you will multiply B, multiply each of the elements, add them together. That will be the first component of the resulting of the matrix vector multiplication. Similarly with the second row and with the third row. So percentage star percentage is nothing else than the operator for multiplying high order objects. Now, if we want to, I told you, if we want to solve this problem, there is a function already provided for you in R. It says solve A, B, so it solves the linear system AX equal B, and the resulting is nothing else than the unknown vector X. Okay. So I think this is interesting if you are working in a field that requires matrices, and there may be plenty or many different ways. So let me just give you another table with a series of operators, special operators for matrix operations, matrix and vector operations. So this one we just saw is the matrix vector multiplication, and also works for matrix, so it's a high order object multiplier. If you wish, this is the outer product operator. It basically takes two vectors and then generates a third vector that is perpendicular to that. Kronecker product This is the modulus. You already used this, or you have used it in the assignment 2. Integer division, meaning that you only want the real or the integer part of the division, and there are others as well. Okay, so there is an inner product one, and so on. So there are a couple of useful operators for doing this kind of high order option manipulation. Okay, just want to have it there just to let you know. Okay, any questions about this? Again, depending on what type of research or programming you're doing, you may run into this kind of option, so it's good to have this somewhere. So a couple more of elements about matrices, a couple more of functions. The dim function, which stands for dimensions, in principle is a diagnostic function. And you will notice we are going to see this hopefully today or next class, depending on the time. This gives you the dimensions of the matrix. So I can say, okay, what is the dimension of A? And then it will tell me in the previous example, A is a 3 by 3 matrix. Okay. Now, this also allow you something weird. It's not many languages offer this feature. But let's say I create a new vector here, and now my vector is going to be a sample, like we used at the beginning. Is going to take true and falses. I want 6 elements of them, and because I only had 2 possibilities, I had to say replace equal true. So I can't keep basically sampling true and falses. So this is the random vector, random Boolean vector I generated. And if I ask for the dimension of A, it will say 6 because it has 6 elements. But I can do something else. I can say, okay, dimension of A, and then assign, remember our assign operator, and then create a vector with 3 and 2. What this will do, it will force the vector into this new dimensionality. So it will have 3 rows and 2 columns. Okay, so I just run this command, and now if I ask what is A, so instead of being false, true, 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 false, just a linear vector, now it blends into basically a matrix, a 3 by 2 matrix. Okay, so this is a very handy way. I think Python, if you know Python, this is similar to reshape. So it allows you to reshape the structure, the form of the object. And now I can basically do the opposite. So 3 by 2 gives me 3 rows, 2 columns. I can say dimension of A being 2, 3. So now will give me 2 rows, 3 columns. Okay. If I take the transpose of A, it comes back to the form because it basically reverses or inverts the number of columns and number of or shuffles the number of rows and number of columns. Okay, so this is again something that you may be interested in if you had to do some type of manipulation of this kind of high dimensional options. Now, one thing that you will notice is that as well as with the vectors, because as I told you, this can be seen as a generalization of vectors, matrices are homogeneous. Okay. So let me take these questions. Change the variable in place, or does it need to be saved again? No, it changed the variable so no, it has to be saved again. Sorry. So when you do T of A, so the question from Richard is let me go back to the example. If I do T of A in this way, does this change A to the previous form? And the answer is no. So you need to assign this to A as well. So this is more seen as a function than anything else. And notice that the only way we can do the reshaping, the changing of the variable is when we assign. And this is again, is if you think about this, it's very weird because, as I said, dimension of A is one of these diagnostic functions, which is telling you information about the object. But by assigning something to that, you are able to mutate the object itself. So T of A is just a function. So if you want to do something like that, you have to say A assigning operator T of A. Yeah. That is how it is. I don't know. It has some usefulness after you get used to it, but it's kind of weird. Yeah. So, okay. Matrices are homogeneous, I was saying. So if we take this last form of the matrix A, and now I take, by the way, for accessing the elements, I use the bracket notation. And you can see this from how R displays this. So column 1 is comma, 1, row 1 is 1, comma. So if I want the element in row 1, column 2, I do A bracket 1, 2. Now I can assign this, and remember this kind of interpretation of R as booleans as 1 or zeros. I can say, okay, A of 1, 2 is going to be 1, okay? And now if I ask for A again, basically R switched all the elements of the matrix to integer values, okay? And notice this, if I say A, 2, 3, that's my second row, the last element, and I assign a word to it, R will do it. And when I ask for A, now everything is a string because this is a word. Okay, so bottom line is R handles this object as homogeneous or uniform. So when you do a switching, then everything is converted into that, is casted into that, as the technical term. And the reason for that, and the reason why this word, you may start to complain if you are familiar with compiling versus, for instance, this kind of dynamical typing that we talked on the first class, is somehow allowed for something called polymorphism in R. So R allows you to manipulate and dynamically change the types. Is it something that should be done or not? I personally think that it's tricky, and you need to be careful. Especially because you can get confused in a particular very long code when you start with a variable or an object, and then you mutate that type of object, and then you say, but that was a matrix of real numbers, now it's a matrix of vector of words. How that happened? And something in the code may have happened, you know. And sometimes, depending on the type of functions or operations that you use, that could happen. So it's something more than anything to be aware, and we're going to see in some cases this happen as well with data frames, which is like the most general option you can think of if you wish. Okay, so let me go into a bit more of matrices, and these are, or more general objects than matrices, these are arrays. And the reason is matrices can be basically two-dimensional objects. And arrays can have more dimensions than that. And if you want to think about a particular case that you may use this, is with tensors. And this can come from different fields. It can be the inertia tensor for a particular object. It can be the energy tensor or the stress energy tensor in a particular material, or if you're doing with physics, it doesn't matter. So it allows you to have more general objects. So it's a generalization of matrices, if you wish. And the usual name they are given is arrays. So arrays are just high dimension versions of matrices. So let's say I want to create an array here, and I'm going to take 12 numbers, 1 to 12, that's my vector. And then my dimensions, instead of being just 2, as in the case of the matrices, like number of rows, number of columns, I will have 3 dimensions. So 2, 3, 2. And if I ask the class of this object is an array, and if I ask what is B, then it tells me, okay, it starts with the last dimension, so 2, and then we say, okay, first dimension in the, or first value in the third dimension is 1, 2, 3, 4, 5, 6, and second is 7, 8, 9, 10, 11, 12. So that's how it orders those values. So you can think about tensors or arrays as high dimensional matrices that I slice it in a third dimension in this case, or a fourth dimension, or how many dimensions you want. Now I can do C in an array, and I pick a not really good name, sorry for the array, you know, because of C, but this is capital C, so I can live with that now. Still not the best pick I have. 1 to 12, and then arrange in 2 dimensions, 2 to 6. And if I ask what is the class of C, now R knows that because there are 2 dimensions, it's a matrix. So it basically converges or recovers the concept of matrices when you had only 2 dimensions. Okay. So that's basically, there are a lot more that you can do with this kind of object, with arrays, but I think that's just for the sake. I don't know how many of you may be using tensors or high dimensional objects, but again, this is something that is available in R, and it was pretty straightforward, I would say. Okay, any questions so far? And now we are going to switch into data frames, which is the next layer or next level of generalized objects, and we talk about them, but because they are so important, and for this week the assignment will be mostly based on data frames, we're going to at least talk about them for the rest of the class today. So any questions about this so far? Looks like we are okay in the chat. Okay. So why I want to spend a half more lecture talking about data frames? Well, turns out that data frames are one of the basic building blocks in data analysis. Not only in R, even if you try to do some data analysis in Python, languages like Python, you will end up importing something called pandas, which is a library that basically allow you to handle data frames, because Python don't have a native data frame implementation. And one way to define a data frame is, if you remember our first week of lecture, is a named list of vectors, which is very similar to a spreadsheet. So you can basically think about a data frame as a spreadsheet. So each vector, a column of the data frame, has the same length, but different columns make a different types. So this is a big difference with the types that we were just talking before. All of them are homogeneous in the sense that all the elements has to be of the same type. In data frames, you are allowed to, one of the beauties of the data frame is that you are allowed to have columns with different types. Each column has to have the same type, but between columns can be different types. And I think I showed you the first week, there are a lot of data frames already as part of R. So as soon as you launch R, you have a lot of them. You can actually, let me see if I can do this. I usually like to do this. I haven't done this much lately because I don't really want to. So let me see. It's too tiny, but in any case, I'm going to just launch R just to demonstrate all the data frames. So if you type data, there are tons of them. You can pick your favorite ones. I think in my slides, what I have here is one called what is the one? Sorry, what? Had trees. So trees is a good one. So if you type trees, you can see that's a data frame. It actually contains the information of girth, heights, and volume. I think it's orange trees or something like that, or a given set of trees, doesn't matter. If you ask for the class of trees, you will say that it's a data frame. And if you ask for the structure of this data frame, then it tells you that it has 3 columns, as we saw when we asked for it, with girth, height, and volume, and the types. So it says all of them are numeric types. There are 31 observations, meaning 31 rows, with 3 variables determined by these columns. So that is giving you a little bit of the information of the data frame. Okay, so that's better. Let me know if you guys, it's okay if I keep this configuration for the lecture. Are you okay with that? Is something that is readable and you can guys see fine? Just let me know. Okay, cool. Right. So I sometimes I can show you some things in the terminal. I'm not sure how much, but if it is needed, we can use it. Now, these data frames are already part of the R package, but you can create, and that is one of the nice things, you can create your own data frames. And one way to do that is to use the data.frame function. So in this case, I'm going to create my data frame. I'm going to do it live. I'm going to say data frame. Okay. I'm going to say, and this is the important part. So this is the name I'm going to give to the column. So I'm writing pants here. And then pants is going to be a vector 1 to 3. And then the second column is going to be called names, or name if you want. I'm going to use capital, write capital here. And then this is going to be a vector of words. So it's going to be Larry, Susie, and Bob. Okay, so this is a vector. I have to close the first one. I have to close my data frame. Okay, so that is my DF, my data frame. if I ask for my df now, it shows the two columns. First column, which I call pans, which has numbers 1, 2, 3. Second column, which I call name, and then Larry, Susie, and Bob. And if I ask for the structure of my data frame, it basically shows these two columns. Okay. $sign notation is also for accessing the columns in the data frame, pans, integers, basically numbers, and names, which are factors. We're going to come back to this, okay? It's showing us factors, and this is a very important thing, and I will tell you why in a second. So I can also get the names of the columns of my data frame by using the names function, and it will say pans and name. And remember how we were talking about the dimension function just a second ago about matrices? Guess what? The names function works exactly the same. So I can rename my columns. I can say, okay, you know what? I want to have the same type of notations. I want to call capital pans my first column and capital names my second column. Okay. So if I do that, I say names of my data frame, and then I assign a new vector, and now I can ask for the names of my data frame again, and now we're going to say pans and names. So it changed the name of the columns by using this diagnostic function again, and if I ask for my data frame, you will see now my columns are called pans and names. Okay. Another way to access this information, this is basically the same, is to use the call names function, call names of my data frame, and give me the same as names. Okay. You can also change or access the row names. So row names, usually this in Excel, if you're using Excel, for instance, it's always numbers. But you could decide to change that. I'm not saying it's a good idea. Sometimes it can be confusing. But basically give you 1, 2, 3, which are basically the row numbers here. Again, something to bear in mind. Sometimes people like to change this to something more meaningful, like sheets or something. It's something that is doable. End rows, the function end row tells you how many rows that data frame has, in this case 3. There is an analogous one called end call, which tells you how many columns you have, in this case 2. Okay, so they are very, very intuitive functions, I would say. Now let's say that I want to add a new column in my data frame. So far I have pans. Let's say this is the number of pans each of these persons own, and now I want to add let's say the socks. I want to add information about socks. I don't know why I went to this row, but whatever. So my df, I can do my def, and something else if I want to access the information. So we covered this in the first week, I believe, but it's just a reminder. If I want to see the column pans, I just do dollar notation pans, or this is going to be important, especially for the assignment, I can do brackets, quotation marks, and this is something that happening in particular in macOS. Sometimes there is a bug and that doesn't allow me to continue writing, so you have to write my df quotation mark pans quotation mark and close bracket. Okay, similar, I can access names by doing that, or by doing the $sign notation. Okay, now how can I add a new column here? Well, I can say $sign socks, and then say something like archive. Okay, and now if I ask for which columns have this data frame, now we say pants, names, and socks. And if I ask for what the data frame has, now not surprisingly, I will tell you why. We have the original 2 columns, but also the third column, which has been all filled with the value archive. Can someone, I'm going to sip my a bit of coffee here, but can someone tell me why do you think R does that? I know it's kind of an out of the blue question, and no without much context. The reason why R does this is, remember the recycling thing we talked last class, or last week at least, where R basically takes two vectors, and if one of the vectors is smaller than the other ones, it basically starts to recycle this smaller one until it matches the dimension of the largest one. Well, that is exactly what is happening here, because I'm doing in the column my socks and saying take the value r child. R says, oh, okay, my data frame has 3 rows, so I'm going to take r child for the 3 rows. Alternately, I could have say something like r child, and then gray, and then yellow. And now, because there are 3 elements and there are 3 rows, basically if I ask each of the values in the column socks, we have that particular value. Okay, so this is one way to add a column to a data frame. The other thing you may want is, okay, can I add a new row, right, to my data frame? And yes, the function you may want to use is rbind for row binding. So I'm going to call this my data frame 2, and I'm going to take rbind as the function, my data frame, the one that we just modified, and then I'm going to say data frame, and then I had to be consistent. So it has to have, the matching happens because of the names in the column. So I had to provide the same, exactly the same names in the columns. So names, pants is 6, names is going to be Shane, and then socks is going to be black. Okay, close the data frame, close the rbind function, and now my df2 has a new row which is similar to my df, but added the 4th row now with the data I just provided. Okay, I could have done this in my df directly, but sometimes you need to be careful just to don't break anything. Okay, any questions about this? The code is quite intuitive, I will say. One thing to bear in mind, so the way I show you how to add a new column here can be also done in a similar fashion with the rbind and the cbind. So there is a cbind one, which is for column bind. So I could do my df2 and then say, I don't know, age, and then do 1 to 4, just to make it simple. And then, as you will see, the new my df2 has now a new column age, and it has the values 1, 4. Okay, or I could be more explicit and say, okay, I actually want 21, 18, 33, and 44. Okay, and in that case, now the data frame has these values in this new column. Okay, any questions about this? So Sisu asks, can I add a new row without type names? For example, rbind my data frame. It's a good question, and you know what? We can just try. So let me just try something like what you are suggesting. So my df, and then what you were saying is data frame, and then I'm going to just put 7, Mike, and red. And this is the problem. So then let me see if I have, yes, so the matching by row bind, and I wanted to show you this so you can understand, or you can start to interpret the errors. The matching has to be done by row names, or sorry, column names in this case. So R will know, okay, there are 3 things here, but because the names in the column don't match, I don't know how to merge them. And I show you why they don't match. So if I ask data frame 7 my red, look at this. The column names are given by x and the value. So in this case, x7, x.my dot, x.red dot. So coming back to your question, the matching in the rbind function has to be done by column name. So it's important that you name the things equally. There are tricks that you can play. I don't want to go into this right now because it will take some time, but if you start thinking about the names function, and you can force things to be named in the same manner and then revert that and things like that. So it's doable, but not right away out of the blue with the functionality that rbind offers. By the way, rbind is one of these super powerful functions. So if you want to know more about rbind, you can do help rbind, and it will tell you more about different things. One thing is the parse level, the names. There are a lot of things here, very juicy things. But out of the blue, in the simplest approach, it won't work unless the name of the columns are exactly the same. Okay. So I think I show you this, but we are going to come back to this because this is quite important. Let's go back to our trees, data frame, 3 columns, 31 observations, 31 rows. If I ask for the structure of this data frame, we have a column girth, a column height, a column volume. And I show you this. If I want to know the girth value, I can do trees $sign girth. So that is accessing using the $sign operator, or I can do bracket, quotation, quotation. So I told you this is a bug that happens it happens again. So you have to type it. Trying to be lazy here. Okay, same thing. Now one is better than the other, and and there is one more way you can access this using the comma notation. So you can access by index of row. So row number 1 is column 1 is comma 1, row 1 is 1 comma. So you notice that? I may have been a little bit confusing here. So trees, if I want to access first column, I can do trees girth, I can do trees bracket girth, we'll know is the column girth. I can do comma 1, which is the first column, or comma 2 is the second column, or comma 3 is the third column. But if I want the first row, I do trees comma bracket 1 comma, and that gives me the first row or the second row, or if you remember slicing, maybe the first 12 rows, 1 to 12. So that is slicing right away in our data frame. I can also do, if I want multiple columns, I can do trees bracket C, and then do by name height and volume. So I'm creating a vector height and volume, so I'm slicing indeed here, and give me height and volume. Or I can do trees bracket 2 comma 3, that's the columns 2 and 3, height and volume. So many different ways of accessing the data. Okay, now let me show you something, and I'm going to go full screen with my slides. How do I do that? There we go. So I'm going to go full screen because this is important. So any questions on how to access data? So I show you different ways to access data, but this is very important when you need to access the column within functions. So I show you the $sign notation and the bracket notation, right? So $sign, we saw that a second ago. $sign, if I go to the history of my commands, you will see there is trees $sign versus trees bracket quotation mark. Okay, so what I want to say is, usually in functions, $sign is not the best approach to use, and the reason is whenever you write, this is I want to call it a flaw, but this is a feature, or neither a feature, is the way that R has these things. I don't find the best way to describe it, but this is how R handled this. When you write data frame $sign, then R expects to receive something that is the name of the column. Okay, as we saw before, maybe I'm going to go back to my double thing so I can show you that. My other screen. Okay, sorry, I'm messing up this one. Don't worry. So you remember I used trees girth, so I need to specify exactly the name of the column here. When I do it in this way, this is not a string, it's a name, it's something that identifies the name of the column. When I do it in this way, I'm saying quotation mark girth, so this is a string. In terms of variables in R, this is a name, it's a string. So it turns out, look at these two functions. So function 1 called SumAnalysis.1 is a function that receives input data. This is going to be a data frame. And then A is going to be from the data frame some column, and then B is other function that we are going to call using this column. Okay. The problem with this approach, with this function, is as it is, some column has to be the name of the column. In the case of the trees data frame, some column has to be girth, height, or volume. It cannot be anything else. Okay? And this is because I'm using the $sign operator. This other function, on analysis.2, receive in this case the data frame, an optional argument. Notice that I'm calling working column, and it has the value of some column between quotation marks, which is a string. And now A is going to be the column associated with working column, and I'm using the bracket comma notation here. And then B is whatever is the result of some other analysis. So that's exactly the same. So the main difference here, the main difference is $sign notation versus bracket notation. And the flexibility, the important thing is that by doing this in this way, we are flexible. We can actually specify whatever function, column name we want from the data frame to be used for slicing the data frame. Is this clear? This is quite important, because you will find yourself writing functions then for data frames, and if you use this $sign notation and you try to pass working column as an argument, I will say, oh, working column is the name of the column, and I don't find it, because if it is called trees, volume, girth, or something else, then I will read this as the name, the proper name of the column. Is that clear? It can be the first time you see this or you hear about this, it can be a little bit confusing, and you will realize actually when it happens to you. So I'm trying to be preventive in this regard and telling you, well, listen, if you are going to use the $sign notation, you may run into this problem, because when R sees the $sign, whatever comes after, it will literally take it as it was the name of the column that you are trying to access. In this case, this is taken as a variable, and so your variable can now have whatever value you want to specify, in this case whatever column name you want to specify for your data frame. Again, this can be a little bit delicate, so maybe we have to take a look at it, play a little bit with this, create a simple function that only slices, so a simple function that slices the data frame will be a good use case for this. Okay? See if we have any questions in the chat. Looks clean. Okay. Let me know if there are any questions. Okay, this is an important point, and as I say, it will probably show up in your assignment when I ask you to create some functions to basically analyze some data frames. I mentioned this very quickly in the terminal, how to slice data frames. So I can do slicing by vectors, in this case trees 1 to 3 for the column girth, so that will give me basically the first row of the column girth, or I can slice the whole second row, just trees bracket 2 comma. This is another way to slice. This is very interesting. I can say from the column girth, right, trees $sign girth, give me the values where the height is greater than 8. And this is where things start to be juicy and interesting, because now you can start to see how you can create some logic, how you can analyze data, right? Now I'm getting only the values of the girth for the trees that has a height that is greater than 80, or whatever condition I want to apply, right? So this is one of the most interesting features, and all boils down, if you go back to our vector class, all boils down to this slicing by conditionals or slicing by booleans, because if I run trees greater than height, maybe I can try that again. Let me see if this works. It did work the first time, and the second time, of course, it did not. So what is my thing? Okay. Oops. So we still have trees data frame, and what I want to show you is that if I do trees height greater than 80, what it will return is a Boolean vector with true and falses. And so when I ask for trees of girth, and then I do this bracket thing, what is returning is nothing else than the values where they were true from the girth data frame. I can actually put this in this way. I can actually get the 3 columns by saying from trees get me only the conditions that happen that. And notice the extra comma here. That means give me all the columns. I could say give me column 1, give me column 2, or I can say give me the column girth, as I was saying in the first example. So that's exactly the same as here. So many different ways to obtain the same information. Okay, and again, I will claim this one probably. Actually, you know what? This one where we do something like this is probably the most flexible one, because now both column names are specified by strings. Okay, now I can start to combine things. I can say trees where volume is greater than 40 and trees where girth is smaller or equal 14, and as I was saying, comma, and then trees creates a new data frame. Okay, so that's combinations of conditionals that can generate new or slice by new data conditions. What else? If you want to update a data frame, so let's say that you detected that one of the values in the data frame is flow and you want to change that. So what I'm doing here is I'm just copying my data frame into a new variable called data. And so I'm going to say, okay, from data, let's do that. Data is trees. And now from data 1, comma girth, that is the original value, is 8.3. Let's say that value was wrong, was a bad measure, and so I want to update to 8.7. So if I do data now, it says 8.7 instead of 8.3. So it's that easy to update values. Okay. If you want to manipulate a whole column, it's probably better to take the whole column first. So if I want to take the values in the girth column, create a new vector called girth, do whatever operation you had to do, multiply by 2 and add 1, and then update the column itself. So in that way, you have things a little bit more under control. Okay. We saw this, excuse me. We saw this also, I think, in the first week of lectures, how to read data. The read CSV function is one of the most powerful ones, and allow you to read not only local files but also files located in URLs in the internet. So in this case, it's an example of a CSV file where you can read it, and you assign that to a new variable. You ask for the structure, it will tell you how it is organized. You ask for the names of the columns, and it tells you the name of the columns. And if you want to know more about this example, there's actually dental data sets from the UK, so you can take a peek at that. Now, I want to show you something else that is quite important. We saw this very quickly at the beginning when we created our data frame, and it was that R was identifying some of the columns as factors. So what are these factors? So factors are nothing else than categorical variables. And what happened is, so let's take this. So this is another data set that is in the ORCAD sprays, and it's too big in my screen right now. But if you look at it, and actually let's just display the first 4 rows. Okay, so it's probably better now. So the ORCAD sprays is a data set that has different treatments for and some different measures for ORCADs. And what happened here is, if I look at the structure of this data set, so looking at the ORCAD Express data set, it says, okay, we had 64 observations, that's the number of rows, with 4 variables, that's the number of columns. The names are decrease, row post, call post. All these are numeric values, as you can see. But this one, treatment is a factor with A levels, A, B, C, D, etc., and then numbers. So what happened here is, because, and if you look at the data frame, so 64 observations where there are 8 different levels of treatment that are all repeated across the 64 observations. So what R does is says, oh, because these things repeat quite a lot, I'm going to save you memory in the computer, and instead of saving the 64 observations, what I'm going to do is I'm going to save the unique instances of these observations, A, B, C, D, E, F, G, H, that's the type of treatment, and then instead of saving the letter there, I'm going to save the positions in the vector where they occur. So this is a very aggressive and very useful and very lean way to store the data in memory. Again, this goes by the name of factors and levels. So the levels are the 8 unique instances of the treatment. The factors are the numbers associated with the positions of these different treatments. Now, you can create factors with whatever you want. This is a very compulsive behavior of R, again, to save memory in these data structures. So you will see this a lot. Usually very useful, sometimes tricky to handle, because when you want to access the data, so for instance, I do ORCAD and then treatment. Now I had those values, it says 8 levels, right? So if I want to do, so in this case are strings, it's not so concerning, but it also can do it with numbers. So you need to be careful, okay? Something to warn you, it will come back at some point and we will take a deeper dive, but this is an important thing to be aware of in R. I'm almost there, I promise I won't take more than 5 minutes. The last thing I want to mention is tables. This is another function, super useful function, because it gives you a summary of a frequency analysis in your data. So if we look again at this ORCA treatment, and I run the table function here, it will basically look at each of these levels and it will tell me how many times appear. And because this was a systematic analysis, each of these levels appear 8 times. Right? But what basically does, it takes all your categories and it counts how many times occur. So you can create your own categories, run table on that, and then it will give you a summary table of occurrences in the data. And there are other examples as well. So you can play a little bit with that. You can have concurrency tables between A and B. So there are 2 vectors, you can combine them and see where they appear. So that's a very nice thing. And again, we may talk a little bit more about this when we do statistics lectures. So summary for today, we'll revisit a little bit vectors as a excuse to dive into more high-dimensional data structures, and the ones that we saw were arrays and matrices. We look more carefully at data frames. This is one of the key elements or key structures in data analysis in R. And we remind ourselves that all the techniques, all the slicing techniques and conditional techniques that we learn for vectors will also apply for all these high-dimensional data structures. I think that's all what I have for today. Just a remind you, we have this new section in the course website with exercises. So far I have posted 3 exercises, optional exercises, just for you to practice. If you find, for instance, that the assignments are easy and you are done with assignments, but you want to keep practicing a little bit more, there are a couple more of exercises. These are not mandatory by all means, but if you want to practice and spend some more time coding, this can be a good source for trying things. And if you want, we can discuss them in class, or I'm happy to take the questions about this. And as I said, they are a little bit more open, not as structured as the assignments. So the idea is that you can explore things here. So it's a little bit more of a sandbox, a playground for you to try things. Okay. I think I'm done for today. Let me know if you have any questions. As usual, I'm going to stop the transmission right now, but I'm going to remain in the chat for a few more minutes. And if not, I will see you on Thursday